Now we can look at applying the quadratic formula to solve quadratic equations. In example 1, we have the equation x squared minus 7x plus 10 is equal to 0. We could solve this equation using factoring techniques that we've already established, but we'll go ahead and look at plugging this information into the quadratic formula to see how that will be applied. The coefficient in front of our x squared term is always our value for a. The coefficient in front of our x term is our value for b, and the constant, or that third term, that coefficient will be equal to c as we plug those values into the quadratic formula. That means our result here will be the opposite of negative 7, since that's our value for b, plus or minus the square root of b, which is negative 7, that value squared, minus 4 times a, which in this case is 1, times c, which in this case is 10, all of that over 2 times a, which in this case is 1. To start evaluating this, we have the opposite of negative 7, so that will become positive 7, plus or minus the square root of negative 7 squared will be 49, minus 4 times 1 times 10 will be 40, all over 2 times 1, which will be 2. So we get 7 plus or minus the square root of 9, all over 2. The value that we ended up with under this radical is greater than 0, which tells us we'll have two solutions that exist. We can go ahead and evaluate the square root of 9, which will give us 3. So we end up with 7 plus or minus 3 over 2. And now we deal with this plus or minus symbol. What we have written here is two different expressions just condensed into one using that plus or minus symbol. The first one will be 7 plus 3 divided by 2. And the second one will be 7 minus 3 divided by 2. So that plus or minus symbol is just condensing those two expressions into one. But then we can evaluate these to get 10 over 2, which is 5, and 4 over 2, which is 2. That means our two solutions in this case are x equals 5 and x equals 2. Plugging either of those values in for x would make this given equation true. We can apply the quadratic formula again in example 2, where now we have a leading coefficient that's not 1, meaning, at least in this class, we haven't covered factoring techniques that would allow us to try factoring and solving this equation. So we would need to apply the quadratic formula. And to do that, we would plug in for b, positive 11. So we'd start off with negative 11 plus or minus the square root of b squared. So that would be 11 again, squared, minus 4 times our value for a, which is 20, times our value for c, which is negative 3, all over 2 times our value for a, which is 20, giving us negative 11 plus or minus the square root of 11 squared, which would be 121, minus 4 times 20 times negative 3. The two negatives would cancel out to become a positive 240. And in the denominator, we would have 2 times 20, or 40. Simplifying what we have under the radical, 121 plus 240 would be 361, which is again a value that's greater than 0, meaning we're going to end up with two different solutions in this case. The square root of 361 will come out to be 19. So we'll have negative 11 plus or minus 19 over 40. And then we'll split this off into the two different expressions that we need to evaluate. negative 11 plus 19 over 40, and negative 11 minus 19 over 40. The first one will give us 8 over 40, which will reduce down to 1/5. And the second one will give us negative 30 over 40, which will reduce down to negative 3/4. Meaning we have two solutions in this case, as we already knew we would, 1/5 and negative 3/4.